Okay, now I think we're live on YouTube, hopefully. If anybody... Get into, buddy. If anybody who's here is watching on YouTube, would just drop a note, if you would, in the chat and let me know that you are watching on YouTube and that it's running. The stream, that is. The way that I enable it was looking a little weird. So I think maybe it was not actually enabled until just now, kind of. Buddy, stuff is not yours. Alone. Thumbs up. Okay, thank you. Live now. Perfect. Okay. Glad that I double checked on that. Buddy, please. Okay. Octopus distraction technique. All right, so we're off to a great start today, but that's all right. Here we go. So now I think we're actually ready to go in. So hello to everyone. First of all, happy Friday. We made it through another week. So if you're here, congratulations, and hope you have a nice weekend and all of that stuff. This is the Deep Dive program. My name is Tim. I go by Foamy Guy on GitHub and Discord. The Deep Dive program is a weekly live stream on the Adafruit YouTube, as well as Twitch, and I think several other platforms as well. YouTube and Twitch, and then the chat is over on Discord, which is the chat that is right down below me there on the screen. So if you want to ask questions or interact or just hang out during the show, you can either head over to the Discord, adafru.it/Discord. We're in the live broadcast chat channel right now, and typically that's where folks will be whenever there is a live stream going on. Or you can join us over on the YouTube chat as well. I don't actually have the Twitch chat pulled up, so if we do have viewers on Twitch, my apologies, but I won't be able to see your chat over there if you want to ask questions or interact. Discord or YouTube are the places to do that. If you are new to this program, you don't know what it's all about, we are working on something called CircuitPython. This is the main website for CircuitPython. CircuitPython is basically an implementation of Python that runs on tiny computers called microcontrollers. There's a bunch of pictures of them here. Sorry, I'm playing cat distraction here to hopefully wear him out a little bit. These tiny computers here, so like you can see on this downloads page, there's a bunch of different pictures of them. These microcontrollers come in all different shapes and sizes. They have all different sets of built-in peripherals and things like that. Each one kind of specializes in its own thing. Some of them have, more or less built-in hardware, like a Raspberry Pi Pico right here is pretty bare bones. It doesn't have hardly any built-in hardware. It's mostly just I/O pins. Whereas something, like this macro pad right here, it's actually got a lot of built-in hardware. It's got a display built in. It's got a rotary encoder knob. It's got 12 NeoPixel keys. It's got a stemma plug hidden on there somewhere. There's all kinds of things built into that one. So these things come in all different shapes and sizes, but the common thread that binds them all together is the fact that all these devices on this downloads page do support CircuitPython, which means we can load CircuitPython on them, and then when you plug it into the computer, it will show up like a thumb drive with a Python code file on there. You can edit that code file, and it will execute the code that is inside of it. And there are special CircuitPython APIs in order to interact with all the hardware that is connected to your microcontroller, be it stuff that's built in like on this macro pad, or stuff that you connect like through these I/O pins on the side here with your own circuit. So that's kind of the quick high-level version. If anybody is new and wants to know a little bit more, I can expand a bit, but that's kind of the brief summary version that we just like to put at the top of every show. That way, in case anyone's watching the VOD, who hasn't seen before, they at least know what's going on. How's it going? I probably will mispronounce it, my apologies, but WJF, how's it going over there on YouTube? Nice to have you. So that's the high level bit, CircuitPython. I will say CircuitPython, it's an open source project. Anybody is allowed to use CircuitPython on your own hardware. Anybody is even allowed to add support to your, add support to CircuitPython for your own hardware. Many of these devices are third party, like this Raspberry Pi. Obviously there's a Citron Technologies, Seed Studio makes a lot of these microcontrollers. Pimeroni has got several different devices in here. Waveshare, I know as well. So anybody's allowed to make their own hardware and then add support to CircuitPython for it. It's an open source project. The way you contribute to it is by contributing via GitHub. That's where the project is hosted. It is, although it is open source and it's free to use, it is primarily funded by this company, Adafruit. This is their website, adafruit.com. They're a hardware and software company based out of New York. They design and manufacture microcontrollers. Many of the devices listed on this page are Adafruit designed and manufactured devices. They also design and manufacture breakout boards that you can hook up to your microcontrollers and do all sorts of things with, as well as other hardware peripherals like RGB lights and buttons and beepers and buzzers and sensors and all kinds of things, essentially. Head over to adafruit.com, get yourself some goodies from there, and if you do make purchases from them, you are helping support the CircuitPython project, of course, since they are the ones paying the folks who work on the project. So thanks to everyone who does purchase stuff from them. One more thing, hey, no pouncing, hey, take your pouncing legs off. Back up here. Okay. Let's have a cat fight here. I'm trying to avoid that. One more bit of, I guess you could say, news before I jump straight into the actual stream. I know we're rambling kind of long this time, but I promise we'll be getting into it in just a minute. But I wanted to highlight this because I think it's a really cool opportunity that's coming up. I found this week. I don't actually know where I found this, but I found this link this week, and I found this hackathon, game hackathon, which has a different term. I guess no, they do just call it a hackathon. What's the game? Oh, like Loomdar. There's a different term for a game hackathon, but it's escaping me. It's escaping me right now. Anyway, though, this is a hackathon that's going on. It's open to anybody can participate. However, there are cash prizes, and in order to be, in order to win the cash prizes, I believe it is unfortunately specific to Canada and United States. So I know we may have viewers in other parts of the world. This particular thing, this is not affiliated with Adafruit or CircuitPython or anything like that. I just thought it was an interesting, event that is going on. If you do want to enter and be able to win the cash prizes, you do have to be a resident in Canada or the United States, though. But this is a hackathon that's ongoing. It lasts for about a month. It did start a couple of days ago, so I think it started on the 17th, and it goes until April 17th. So there are about 24 days to work on a game at this point, and basically this hackathon, I believe it's like presented by Microsoft or funded, I suppose. The cash prizes and things like that come from Microsoft. It's pretty wide open. It seems like you can build pretty much any kind of game you want using Python. And I think that's a really cool thing. I don't know for sure if I am going to enter, but I am considering it. If I do enter, I believe it will be a CircuitPython game that I work on. So if anybody else is interested in game development, I will drop this link in the chats, and I will try to remember to submit this one to the newsletter this week. I have not done so yet, so I can't promise that I will remember to actually do that, but that's what I want to try to do, is submit that to the newsletter, hopefully this week. That way there are still about like 3 weeks or so left in it by the time we get it in there. That way we can help get the word out, and folks will still have time to actually work on their game. So if you're interested in game programming, check this out. And if you want to make a CircuitPython game, I believe that's fair game, since it's an implementation of Python. So that'd be super cool to see folks build out games and enter for that. Okay, and now into actual what we want to work on today. What I want to try to do today is follow this guide about how to add a board to CircuitPython. In particular, what I'm interested in, though, is adding a board that has a built-in display. And I'll be testing this out. I'll be tinkering around with boards that don't actually have built-in displays. We'll just have them connected through extra wires. But technically, it's going to kind of work the same as if it were actually built into the PCB itself. I've got the camera pulled up here, so I'll show you right here we have a Feather RP2040. This obviously has no built-in screen on it, it's just a Feather. So what we're going to do there is we'll be able to plug in, we'll be able to plug in some of these feather wings, like this joystick feather wing, or something like this one, or something like this one. We'll plug those in and we will try to wire them up and make a build of CircuitPython as though it were a built-in display, more like this one, which is a Feather TFT. This one does actually have a display just built right into the PCB there. And so, I'm not necessarily intending to add these boards to CircuitPython so that they show up on the downloads page like we were looking at. I'm going to be following the process that would ultimately, end with you adding a board to this page. But my intention is not necessarily to actually add them to this page. My intention mostly is to practice the process, figure out if I can do it or not, and figure out how to do it. And in particular, how to add those built-in displays is kind of the main thing I'm interested in. So which one do we want? I actually have a handful of these things here to try out. Which one do we want to start with? So for sure, we want to start with one that is SPI display. TFT backlight controlled by I2C. Any color. So I don't know for sure if this is a SPI display, but I'm going to look that up, and if so, then that's what I'll start with. This is a joystick featherwing. Okay, so this one's using the helper library, which kind of does all this stuff for you. We want to see this. Go to here, yeah, here we go. Simple test. Okay, yeah, this is looking good. This is a SPI bus. Turn it into a 4-wire. Pass it to the display constructor. Okay, so this should be a SPI display. I think we'll start with this one. I'm going to plug it in. To start with, we'll run this simple test here just to make sure that our circuit is actually good. In this case, it's just a Feather doubler. Everything's all just plugged in, so there's not much of a circuit going on there. So hopefully we'll just light that up and it'll be fine the first time. Do we have this on? Not yet. Let's do that. Okay, you can see backlight turns on, but it won't actually do anything else yet, most likely, unless there just happened to be code that initialized it on there, which there probably was not. There is Ethernet testing code. We can overwrite that because that's in the Ethernet library. I don't know if all these pins are right. Let's look in this library as well. The the next level up. So this is the display driver. Let's make sure this is display IO as well, right? Yeah, okay, it is. Okay, so this is the display driver, but there is also the Featherwing library, which is what this example is doing. Instead of actually directly using the display driver, it's actually using this Adafruit Featherwing, importing the mini TFT Featherwing, and then all the initialization actually happens inside of there. And it gives you an easy to use interface to actually access all the hardware on that Featherwing. So let's look at this, because this will tell us if the pins are the same. Not going to worry about buttons yet. I wonder if we're going to have trouble with the backlight. Since the backlight is connected through the Seesaw. Not sure. We'll see. Hopefully not. Hopefully we can, hopefully if we don't initialize it, it will be on by default. That would be ideal. So that's just going board SPI and then DCCS, which are defaulting to D5, D6, which defaults are passed here. Assume that's where that's at. Yeah, right here. So those are defaults. And so we are getting D5 for CS, D6 for DC. And that is D5 for CS, D6 for DC. Yep, that is the same. Okay, reset. They're using reset, it looks like. Where's this? Reset is past a 4-wire. Interesting. Reset? Reset the display via... Oh. This may not be the best one to start with. Yeah. Because the actual it is weird that it doesn't pass it to here though, right? Feels kind of weird that it doesn't pass it to there. I don't know if it would be able to though, because it's not a I don't know, it's a Seesaw digital in out, not a microcontroller.pin. Let's try without it. Kind of don't think that will work, but let's see. This is the size. Actually, let's take all of this stuff. I think we'll need all of that. Okay, save that. It's probably crashed for not having the right libraries or something first. Yeah. Let's go circup, install. I'm just gonna do auto actually. Oh, new circup. code's running. Doesn't actually show anything on the display though. I think it's got to be that reset pin, most likely. So if we cheated, kind of like we did this. Where's that? That's before the 4-wire. So we don't. This won't be self. Be a class, no. So I'm going to try this to confirm, but I think what this is going to confirm is that we can't actually... It's not going to be as simple on this one, because it would have to initialize the Seesaw in addition to the display. It would have to initialize the Seesaw in order to be able to initialize and use the display. Which is a bit harder. I don't know how to initialize the Seesaw from in the core. Maybe we could look at something else. Maybe there's one that has that happening. What is address? Is address blank? So I will try a different one. If that turns out to be the case. Button mask. I feel like we shouldn't need this, but that's all right. We'll get it. Oh my goodness, right. Those aren't declared. Yeah. Okay. Yeah. Should it set it back the other way too, or? Yeah, I don't know. Seems like it just sets it to true and that's it. We actually don't need button mask this. We don't need. That's for the buttons. That is for the buttons on the Featherwing, which we're not interested in right now. So create the Seesaw, set the pin number 8 to output, write the pin number 8 to true. And then basically do everything else the same. Nice. So the size is off a bit, I think. Maybe it's a rotation thing. Yeah, I think we probably want this. I mean, technically it doesn't matter, I suppose. But it is looking like we would want these switched, right? It looks like it's not drawing here, and it's drawing too big this way, so I'm guessing that these are swapped. Which board is this one? Good question. This is a Feather RP2040, and then it is a mini TFT Featherwing. Or I think it's joystick Featherwing. Mini color TFT with joystick Featherwing. So it's that Featherwing connected to a RP2040 Feather. And in my case, it is connected with a Feather tripler. So that did not work either. Okay, so first things first, is this actually... Oh, okay, no, yeah, this is just doing 128 by 128, which totally is not respecting the size of the display at all, so the display is actually initialized fine. Anchor point. Middle. There we go. All right, now we're all set there. Seesaw. Let's look at... what's the glasses one? The not the newer like RGB lights glasses, but the Halloween glasses, the eyes. It's not Halloween. I'm still learning to wrap my head around the Seesaw. Not the simplest board to start with. That is true. Yeah, the Seesaw is like a. I think of it almost like a like microcontroller Swiss Army knife. It's like a little widget that does a little bit of everything. And it lets the main microcontroller kind of offload some of that work over to this sort of secondary one, and it's very what's the word, like adaptable. It's very, can do many different things. It can be set up in lots of different ways. Oh, I'm trying a name on this. Intelligent I/O expander. There you go. What is the Halloween eyes one? Gosh, Monster Mask. Monster Mask. That's what it is. There we go. This has a Seesaw built in. I don't know if it uses it in here, though. I kind of doubt it, but maybe. No. See, because I think the thing here is that the main screen, whichever one is considered the main one, has pins wired directly, like for the reset pin, for instance. The secondary screen, because this board happens to have two screens, the secondary screen I do think is wired through the Seesaw. Yeah. Yeah, we'll probably try a different one. Let's try this. Does this get us anything? No. I know there are more devices with the Seesaw built in, but I don't think there are any, or I should say maybe I don't know of any where the actual display pins are on the Seesaw rather than the main microcontroller. I get Pi Gamer. I don't think it's gonna be that way. Pretty sure this has a Seesaw built in though, so it's like part of the way there. No. Well, let's do something. It's not importing I2C for anything, so I kind of doubt it. No. Excuse me. Okay. So that one's a bit tough because the display reset pin is actually connected to the Seesaw. 128 by 64 OLED. OLED featherwing. I think that this is maybe I2C, which we don't want to start with either. Doesn't the circuit have one? I'm not sure what you mean. Doesn't the circuit have one? The Seesaw? It does have a Seesaw built in to the featherwing that we were looking at, but I don't know how to initialize it and do stuff with it from inside the core. I know how to do it from the CircuitPython level. Well, I unplugged it now, but like the code we had in here is how to do it from the Python code or the CircuitPython code. But I don't know how I don't know how to do it from inside the core, or if it's possible, to be honest. I mean, I'm sure it is possible, but is this an I2C display? Or is it a SPI display? Display. I2C display. Oh. Either? Is it? No. When did I2C? Can it be SPI? Probably not, right? So this is where I want to get to eventually. I do want to try to add an I2C display, but I don't think any other existing devices use I2C displays. And so I want to start with something that does exist, just so we're not like in unknown territory right out of the gate. Yeah. Although it does. But this is saying that the display can use I2C or SPI. And if you use SPI, then this pin on the display would be MOSI. This pin on the display would be SCK. I don't know why they're like crossways. I'm not sure why that is. But on the feather, though, this is meaning that it's only on SDA and SCL, which is I2C. 12, 13 aren't hooked up. Just using SPI pins to run I2C. Well, I think I think on the display side, basically those pins work as either. But in this Featherwing, they're actually hard-coded, I believe, to these SDA and SCL. If we had the display module by itself, like the raw display by itself without the Featherwing, then I think we could feed it SPI. But it looks like the pins aren't broken out. So that's I2C. So not to worry. We can use either iSpy or I have 3.5-inch Featherwing, which this one I'm pretty sure is SPI. But I'm going to go with iSpy first, because iSpy is definitely SPI. Is on a Pico W, is a micro USB. Here to not have on. Done with my micro USB cable. Okay. Unplug this. Ooh, get it out from this. Oh, that's fortunate. Okay. All right, 1 second. Okay. Sorry, it occurred to me partway through that I probably should have muted before I did that. I apologize if that was loud. My microphone stand arm thing came off of its mounty bit. Let's see here. We need more ESP32S3 stock. I would say personally I'm pro more stock of everything. However, I don't have any say in that matter myself, or even any kind of insight or anything else about it, truthfully. I am remote. I'm not actually at the Adafruit factory, and I don't do anything like physical. Everything I do is software. Wish this was like a touch smaller. I'm just gonna put it out here. You can't see the circuit anymore, but you can see the display, which is like the important part. Okay, so this is using a ST7789. It is using SPI, going through 4-wire. We will need to select the pins because it's not... It's a Pico, therefore it doesn't have board.spy. We're going to have to probably add board.spy, actually, which I think it's not really intended to do on this device. But I think we will actually need to add that because if we don't add board.spy, that means that user code is not going to be able to do anything with the SPI bus, right? Like, it would have to initialize it like this, and it will raise an exception that says the pins are already in use. Or, it could release them, and then they wouldn't be in use, but yeah, I think we'll have to make a board.spy, actually. Display datasheet indicates that the interface protocol is pin selectable. Okay. I2C, communicating protocol select. Interesting. Let's take one more peek at the product listing. Sometimes there's a jumper. Situations like that. Bottom side. Like address. Reset. Why that's like that. See address. Yeah, unfortunately, it doesn't look like it's broken out on the Featherwing. The way to jump that would be kind of interesting, though. Wait a minute. So that's interface. That says 5. Is 5 broken out to anything? Oh. Kept this open. 5. It's tied to high, which is I2C. Yeah. So we're hard-coded to I2C. We'd have to break this somehow and tie it to ground instead, and then wire MOSI and SCK into these two in order to be able to do all of that. Thank you, though, for checking out the datasheet. That's actually cool to have confirmation, and even, if I'm honest, it's cool to be able to actually see the wiring diagram, circuit diagram there, and actually be able to tell what's going on with it. Been up all night, made 2 PCBs and a 3D printed design. I'm bushed with will fall asleep watching you, though. Oh, nice. Yeah. Wish you the sweet dreams. Have a good night and all that stuff. Definitely do get some sleep. Nice to have you here for a bit while you're awake. Okay. So in this case, I think we need to make a board SPI, and then we can hopefully do the rest of this stuff to initialize the display. So I'm gonna go to core. Should have updated before I started, but I didn't, so I'm gonna check out main. Gonna update. It's probably gonna take a minute. I apologize. Should I do fetch submodules? Probably should. Let's try without. Well, no, we should probably do it. Let's do the pull and then we'll fetch submodules. While that's working, we can start looking in this stuff though. So I'm going to be going to Raspberry Pi. I'm going to be starting with a copy of Pico W because that's what device I have. I'm going to basically take a copy of this. But we are going to do some more stuff inside of board. This update canceled. Why with the update canceled again? Why can I not just update, please? Even show me what files. Why are you different? I did not change you. Get reset hard. But that's not going to pull. I have to pull after. Able to render directory not empty. Head is now this. Please actually update. No, don't clean. Don't make anything. Just pull. It still shows those. It's not gonna work. I really wish I knew how to recover from this state. Now it's two different files. I don't understand why I cannot tell it to throw away whatever changes are on my local one and take whatever's in the repo. I don't care that we can't save my stuff and bring it back, because I don't even really know why it's changed. It's not actually my stuff. I don't understand how it got changed. I wish I knew how to tell it to throw that stuff away and pull main. Just park me on whatever the current main is. I consent to having whatever needs to be deleted or undone happen. Come on, buddy. I don't understand why it's so slow either. I wish I could see more output too, like just kind of takes forever and then it's done. or it takes forever and then it fails. It's not done. It's going to take forever and then it's done though this time. I feel like it's even slower than like cloning a new one sometimes. Like I don't get why pulling, even when it works, like pulling takes kind of a long time for this project for me. But a clone doesn't, I don't think, it's canceled for no reason. It's canceled. I'm not going to tell you why. It's canceled. Don't worry about it. It's kind of frustrating. I think I used get rebase. Yeah, I don't know how to do get rebase. I need to learn apparently, I guess. Apparently. I feel like I shouldn't need rebase though. I feel like it should be really, really much easier for me to throw away whatever changes are preventing me from pulling. Like event window. I don't know, there's just like no output for that, so I just can't see why that failed. Now these things are different again. Oh, that is kind of frustrating, to be honest. See, like, that was a full clone right there. That took 4 seconds. But in here, it was like almost a minute or two, right? And then it didn't even succeed. Like, I don't see where the time difference. I already was in another of these, right? Like, I keep making these because I keep eventually getting into a state where I can't recover. I wish I could disable that somehow. Huh? Did I spell that wrong? Oh boy. I feel like we're one thing after another with this one today, huh? Get submodule. I don't think I've ever seen that before. Usage. Get submodule quiet. Boy. I don't even know. I don't know what to do. We can't make a build without getting the submodules. I don't know why the submodules aren't working. Filter blob none. It's not even this, like, not even a useful error message here because there's nothing to like search really, right? It's like basically telling me that I just have wrong flags or something. Like it's saying like this command doesn't work the way you passed it. And then it's saying like, here's all the options for the way that it can work. But it doesn't say like, you know, this part is the part that was wrong with it or whatever. It's not like unknown thing filter. It's just like usage. Here's how you use this. Init. Oh boy, I feel like I'm taking 10 steps back, 0 steps forward right now. Am I not in the right directory? Is it need fetch? Regular fetch? I don't know what to do. So I guess we just can't use this new clone. Error 1. You need an up-to-date version of Git. How do how do we get that? 0.39. This just says installed and not update. Okay. When did that change and why? Okay, we're not just gonna old man complain about updates. We are like miles and miles into the rabbit hole here. Why are we using one that's not? I don't really understand. That seems kind of crazy to me that suddenly we need a version of Git that is so new that you can't install it on pretty much the current version of Ubuntu. Is there like newer Ubuntu at this point, I guess? Like, and this is not mentioned anywhere inside of here, so it's kind of on your own to figure out how to get it. Even is the recommended version? I don't know. That's kind of not ideal. Submodule update init. Run this as 3 commands, probably. don't get how that becomes broken like that. How do the VMs inside actions do it? Filter is too new. Did we change something to use filter? Can I just not use it? I feel like this worked 3 days ago. I don't, it feels like we just have no working process right now. That's the case. Can I take this off? Three days ago? Submodules update. Submodule update. Yeah, you and me both. Yeah, I though. Noticed. Sounds like the music player was killed. I was like, why do you think I'm looking at you? Trying to restart the music. In and out could be totally off base. Are you in a custom Python environment for CircuitPython builds? Not currently. I'm in. Actually, the truth is, I don't know. The short answer, truth is, I don't know. I think that I am in not a virtual environment and instead am in Python 3.10 that is installed inside my system. Yes, I know they say to use virtual environments. Sometimes I do, sometimes I don't. I believe I'm in my system one. Let me read the rest of this as well. I had a while back. No. I had an issue a while back where my base environment was polluted and Git and CMake weren't working well. I created a new environment and it worked, I think, because GCC didn't have a bunch of conditional linking taking place that my base environment had as a result of Anaconda. I have never used Anaconda. I have heard stories of stuff like that, though, where it's different than regular Python or whatever. This feels like a different issue, but who knows? Yeah, I'm thinking Neradoc is probably right here. I'm thinking this issue is from this change here, where we started having this. And this apparently does not work on anything except the brand newest Git, I guess, or whatever, like version of Git that is too new for me. Time for me to hit the hay. Yep, good night, Dave Odessa. Thanks for hanging out for a bit. Sorry we didn't really get into the actual doing of the stuff, but hopefully you at least had an enjoyable time watching me troubleshoot. Should probably revert the change. I agree. I don't feel like I necessarily get a vote. I don't feel like it's really my place to have an opinion one way or another, because it's also beyond me what this means or what it does or what the upside is. But looking at the downside, which is that this page is no longer accurate and there is just no way to follow the instructions on it, I feel like is a pretty big downside personally. So while I don't understand the upside of the change, it would have to be a really, 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 really big upside for me to think that it was currently worth it to be that way. Now, if it was just as simple as like sudo apt update git or whatever, right? Like if that was as easy as it was in using the stuff that we say is recommended here, that's not so bad. But seemingly there, I don't even know. I guess I would have to build it myself. I'm not entirely sure how you would get a newer Git. This one kind of seems like it worked, so maybe we're good here. So I'm just gonna go boards. We're just gonna try to make Pico W with no changes. Make board. Yeah. now's a good time to mention, I guess, if the stream cuts out, it's probably because my computer froze. Fingers crossed that that is not going to happen. But I also still have this segmentation fault problem. Isn't there something about Raspberry Pi needing a different... okay, not Raspberry Pi Pico. Raspberry Pi Linux. Okay. So no, I have the right one. Just died partway through, so fingers crossed. I'm gonna try again. I hope my computer doesn't crash. Can't watch. Not letting my guard down, but it feels like we're doing pretty good so far. Overflow hook? Nick abort? Okay. We gotta build. Boy, I feel like I have been on quite the journey already. This. So to start with, I'm gonna, nice and easy, we are just gonna make a complete and total copy of PicoW with no changes. I'm not even gonna worry about trying to add pins or displays or anything. At first, we're just gonna duplicate it straight up and see if we actually can get a build of our custom different board. I don't need to add any of it to the repo. I'm not going to commit or check in any of this stuff. Should probably start a new branch, truthfully, though. Oh, please don't do a whole nother. Okay. Is the heap corrupted? So is that all you need? So at this point, am I theoretically thinking that this should work? Oh. I'm at a bit of a loss on the segmentation faults. I don't know really what else to try. Guess I can't say that I've tried that much, but I've tried everything I could think of, which is updating everything that I can update and swapping RAM, thinking maybe the RAM was bad, but I have still seen segmentation faults with the new RAM, so starting to think maybe the RAM was not actually bad. But what else can cause the segmentation faults so randomly during the CircuitPython builds? Maybe I'll switch the RAM to the other slots. Maybe one of the slots is bad or something. Okay, that's actually that was pretty easy. Of all the things I've done today so far for this, that was definitely the easiest. So that's actually, yeah, that's really straightforward. We don't need to mess with too much here. I'm not gonna mess with any of this stuff, honestly. Anything in here, I don't think. Theoretically, I guess we could change these. I'm not even gonna do that right now, truthfully. I don't know what this stuff means. Not gonna mess with that. I think board and pins is technically where our changes are gonna be. And I guess what we're gonna do is look at the Feather RP2040. I wonder if is this a bad one to do because of the Wi-Fi chip? Is the Wi-Fi chip also on SPI? Wait, what? This doesn't have a stemma. That's interesting. Oi. Only thing that says SPI in here at all is this. There's no SPI in here either. Okay, here's where. Is it? No, SPI, but yeah, okay. Semi to. Is the. Interesting. convenient, but a bit awkward since it's not part of the main board. So I'm pretty sure we're gonna need these. We don't currently have them. We're gonna have to figure out which pins to use. So clock is GP10, but the problem is I don't think it's actually just GPIO 10. It's GP10 here. It is actually GPIO 10, I think. Okay. I'm not gonna make it. I'm gonna have to run to the restroom, so I apologize, but I'll be back in 1 minute. Okay. Got a regular Pico so far. I played with LCD 20X4. Any advice on what to buy or play with? What to buy to play with for the Pico? Boy, LCD 20-4. I assume that's like the yeah, one of these ones is what I was thinking. Okay. I mean, that's definitely fun. Personally, I'm big on displays, so like I'm always down to play with display IO stuff personally. I mean, I don't know if that's what you're into as well, but so I mean, on some of my Picos, like we were just talking about that cowbell, which is like kind of a multi-purpose breakout for the Pico. I've got a couple of those wired up to allow me to attach other displays. Just the kind of stuff that I tend to, I don't know if you can search that way, but maybe TFT is probably. So there's like all the I Spy ones with the ribbon cables, which is like what I've got hooked up here. There's ones with the ribbon, so it's like an I Spy breakout. Well, the I Spy breakout is this thing over here. And I have mine connected up to a Pico even. And then ribbon cable from the breakout to the display. And you can actually use the pins here if you want as well. You don't actually have to use the ribbon cable. That's the kind of stuff I tend to lean towards, but yeah, I don't know. I would say it depends kind of on, yeah, on the projects that you're interested in, different screen or sensor. Yeah, sensors are always good for a basic thing to play with, maybe temperature or humidity or something relatively basic like that's always a good one to kind of tinker around with. So that's going to be 10. MOSI is 11, which is actually straight through to 11. It's nice these line up, actually. I think that's not always the case, but I'm not sure. And so we don't really need MISO, I don't think. I guess we should figure out what it is, and I assume it's going to be probably 12, right? That's, yeah. GP10, GP11, GP12. The GP numbers are the ones that we're on for this. GP12. So this, and then we need a thing here. Or spy. I think. I don't know if it matters if it's before or after that. Okay. So if that worked, we should be able to make a build and have a board.spy, I think. Let's just take a quick look and see if there's anything else spy in any of these. No, doesn't look like it. Okay. All right, so fingers crossed. Did we clean? I'm gonna do no clean. I'm basically on no clean until further notice, just because, like, if it doesn't clean, then I think it doesn't have to compile as much, and if it doesn't have to compile as much, then I think there's less chance for the segmentation faults. Now, what I don't know, though, is if you don't do a clean, is it actually going to pick up my changes to my board files? That part I'm not sure. May not. The cowbell breakout thing is kind of nice, too, if you have a Pico, because it has the reset button on it. I got spoiled by that a little bit when I was using the cowbell, which comes to mind right now because now I have a build that I'm ready to install. We need to get to bootloader, and I don't have the cowbell. So what we are gonna do is use the boot select, which you can't actually see, but I'm gonna hold the boot select button and essentially just unplug and replug the Raspberry Pi Pico W, which is going to get us to bootloader mode so that we can copy this firmware to, you need to copy it to a place. You can't just copy from a thing and not to a place. How that works. Tim C. Rooker, yeah, that one. Thank you for the help, Neradoc, if you're still around. Thank you for the help on the make stuff. I would not have probably known how to pass that without your help, so super duper appreciate it. Okay, so that rebooted, came back up. This is still working, which is interesting, but I guess it does. Yeah, I don't know. I'm kind of surprised. I feel like that means it's likely that this is not working. Because if this were working, then I think that this should have failed from user code. It says spy though. It does say spy. What if we try board.spy? Hey, okay. Nice. So we added spy bus. Now let's go find a display thing. Maybe, do we not actually need the spy? I feel like that's necessary, though, if you want the user code to be able to use the spy bus. I don't know, though. I don't think we need that one. Cowbell looks useful, thanks. Yeah, for sure. Delay get used for? That's... system. What is this delay? Why is there a delay defined, but then... Oh, this one is actually used. Okay. Yeah, this one's used a couple of times, actually. Okay, fair enough. MacroPad, I guess. For whatever reason, MacroPad has delay, but it doesn't get used for anything. Doesn't seem like. Okay. So I'm gonna steal, I think... Start stealing from Pico System and see where that gets us. I think we'll need pretty much all of the same imports. And I'm gonna take this up to here. Init sequence is gonna go inside there. Coordinate. So on the Pico system, does it show by yeah, so we basically just are going to use the same ones in here. So for us, that's 10 and 11. And then null is for the miso, which we don't need. False, spy, bus. These we need. So 13. No. 13 is CS. DC 6. Reset is 9. Baud rate, I'm just going to leave alone. Instruct display. Is actually 240 by 240. I wonder if is the Pico system the same display? Boy, that would actually be pretty convenient, right? So I know it's 240 by 240. Say anything about chip? LCD and backlight. Let's say which thing it is though. Don't know. Probably not. Okay. Have row start 80. Doesn't actually say anything about like row start, false start. It always says row start 80, so I guess I'll leave that. But not touch call start. I'll leave rotation alone for now. All this stuff probably. Backlight pin, I guess. I don't know. Not 12 though. 12 is one of our spy pins. I don't think we're using the backlight pin. Does backlight get broken out through the iSpy ribbon cable? It's not the right path. Where's the I want the breakout. It's not it. That backlight? Light? Line connected? Gonna bed, head out for the evening. Thanks for the lovely stream as always. Cheers all. Yep. Thanks for hanging out. Keith the E. Nice to see you. We'll see you around next week if you're around for that. Let's see. Have light is just not plugged in right now. Yeah, not plugged in. Let's just pick a random pin that we're not using. Where's that pin out? I'm definitely not using. Okay, this is flipped around on me though. I'm definitely not using GPIO 0 right now. So we'll just set, we'll just set the backlight to that even though it's not actually connected. And it'll just not do anything. Well, it'll toggle that pin, I assume, or something, but do anything else. That's not the display we're using. Did I say 0 and then put 1? I think I did, right? There is a 0. Oh, but it's only 1 0. Oh. I don't think we want zeros on those. I got confused with the O. Actually, maybe that's already? That's, I think that's already an O. Yeah, it's already an O. Fair enough. Okay. Okay, start sequence. But what is the right format? So this is basically 3, but that one's more. They're basically comma separated. Some of them are hex. Some of them are just int. What we have here is, I guess, 3 sets of hex. I guess let's try to put them in as 3 sets of hex. All right. Would have worked except for I screwed up the do. This feels like some like ancient arcane mystical spell. Get all these numbers in just the right spot, send them just the right way. Mystical pixies will turn on inside the flat black box. It's not perfect, but closer than what we had before. Okay. I don't think we're using this. I'm gonna, oh, I don't even, okay, I was gonna say, I don't know. Try commenting this out. All right. Fingers crossed. GPI. Oh. Yeah, oh. Same thing. That was really fast. Do we think that actually got the real stuff in it? I'll try it, I guess. Is there a reboot to bootloader from the REPL? Is there a way you can do that? Isn't it like, can you do like microcontroller.reset or something like that? Oops. On next reset. I think you can call this and then call reset. Nice. That's actually super convenient for this one without the reset button, honestly. So next we would need to basically change this code, I think. But I don't know exactly, other than just basically unplugging and replugging, I don't know really how to check if it worked because we initialized it in the core, or if it worked because our old CodePy actually was doing the initialization for us. So I'm actually just going to unplug, replug. And if we get a display, which we did, which is awesome, that means this worked. Because now I have no setup in here. All of my setup is inside of here. And okay, so we should also be able to go, let's do this. It's upside down technically, but you know. Oh no. Okay, we don't have display though. We don't have display. So it initialized. It's working correctly, I think, but it didn't add it to board. I think that means we missed one of those things, right? Like inside pins, I think is this? This should be another one of these, I think, right? Yeah. Wrong file. Should we have a comma here? No. Were we ending on a comma before? I feel like we must have been ending on a comma, probably. Whoops. It's interesting. It's doing more stuff this time. I guess it knows some more things changed. I don't know. What was that? Oh. Oh boy. Oh. No? Okay. Thought that was probably a segmentation fault, but no, I think it's just something with the display. Undeclared. We need to do something else. What else do we need to do? Display. That makes sense. That's probably what we need. I will be winding it down here pretty soon. I want to see if this works and maybe test a few more things on it before I go, but I'll probably be wrapping it up after that. For anybody that's interested in this type of content, I do also stream on Saturday mornings at 10 a.m. Central Time, which is tomorrow morning at 10 a.m. Central Time. That's about, well, so we're 10 minutes past the hour now, but if we pretend that we were at the top of the hour, so if it was 6 instead of 6:10, that would be 16 hours from 6. So whatever time zone you're in about 16 hours, I am going to be streaming again on my own channel. If you are interested in hanging out or watching along, you can head to that live broadcast chat on the Adafruit Discord, and I'll drop links there when I'm about to get started. I don't know exactly what I'll be working on. Maybe continue on this kind of stuff, or maybe work on some other things. I don't really know yet, but that'll be tomorrow morning for folks that are interested. It's interesting we still have like whatever was on the display before. Doesn't like clear itself when you go to bootloader or anything. Okay, and unfortunately it printed before our TO connected, so we don't actually get to see the list in here. I'll just do it again. It doesn't have display. It does. They're in alphabetical order. Did it have that before? No. Okay, thank goodness. Jeez. I totally was looking in the wrong section here. I was looking down here for display, and I decided it didn't have it, but the truth is it would have been up there. And we do have it now, so can we just start using it like a normal built-in display? Because if so, then we succeeded, and that's awesome. So let's just do something basic here. Let's get a bitmap. Let's get some imports. Let's get a bitmap. Bitmap, that's gonna be what? Height, width, colors, I think. Height, width, let's go, well, let's go all the way with it, right? Display equals board dot display. This is gonna be display dot width, display dot height, colors, let's call it, I don't know, 4 maybe. Could make this bigger. We need a palette. We'll go 4 on that. Palette 0. Green, pink, yellow, blue. Thank you for the stream. See you for coffee tomorrow. Yep, we will be back. Not quite bright and early, but definitely coffee time. 0, 1, 2, 3, 4. So we have a palette, bitmap palette. We need a tile grid. Tile grid equals tile grid. Bitmap is bitmap. Pixel shader. Pixel shader is palette. We need a group. Main group. Display dot group. Group. Main group dot append the tile grid. Let's go bitmap dot import bitmap tools. Bitmap tools dot fill region. BMP 00 display width over 2 display dot height over 2. How's it going, Quinn man? I'm playing around with some CircuitPython displays. We basically made a custom build of CircuitPython that is for this Raspberry Pi Pico W, and we added this display to it so that now the display shows up as a built-in display, even though it is actually not built-in. Of course, we have it wired on a breadboard here. This was kind of an exercise in trying to add a board to CircuitPython, and in particular, adding a board with a built-in display, which is something that I've never done before. We ran into our fair share of trouble with various different aspects of the process, but we did eventually make it there, and I'm feeling pretty good about it. So now I'm just testing it out by drawing some stuff on the display real quick. Let's start with that. I was gonna do four corners basically with different colors, but let's see if we even doing good here. Display.show main group while true pass. Save it. Yes, that is working. We have the other corners are colored in also because of that is the weirdest green color. The green is so yellowy. Interesting. Anyway, everything started with 0. So that's why actually everything is 0. If I do like 1 and 2, maybe that would give us 2 different colors on the top there. Okay, so let's fill in the other 4 corners. So that will be, let's go 0, and then that's display height. Go there, go like that. Actually, we can get by without the last one because the last one defaults to 0 anyway. Nice. This line running across, if you can see this line, that's just on the protector. I haven't removed the protector yet, and it has that drawing on it. It's fine, though. But yeah, there we go. That is working using board.display, which is awesome. That is exactly what I was going for. Feel like I've definitely learned a lot. I would say, what are the things we learned? Oh, you know what I want to try, actually? Do we actually need SPI? Can we get rid of this? And if so, what are the consequences of it? I think actually is the thing too, because like we can get rid of it, fine, no problem, I'm pretty sure. And then there will no longer be board.spy. But if your user code then wanted to do anything with SPI, I don't think you could. Well, with the same SPI bus. I will say too, the Raspberry Pi Pico throws a giant monkey wrench in the discussion of SPI bus, generally speaking, because there's actually like 2 different SPI buses, and then they're also like somehow pin morphic or whatever. They can be on like a boatload of different pins. Like somehow they change themselves around inside of there. It's actually really strange the way that works. So like these are the pins we're using for our SPI bus. It's technically SPI 1. You could use like this is a SPI 1 pin, that's a SPI 1 pin. These down here are SPI 1 pins. So there's like a whole nother set of them that we're not actually using that technically go to the same bus, even though they're on different pins. I get how that works. But anyway, so on the Pico, it's kind of unique in that you could actually just use the other SPI bus, I suppose. But if you wanted to use the actual one that the display is on, I'm pretty sure that we would actually need this in order to let the user code be able to access it. I wish this had tab complete for the files in the root. That'd be pretty sweet. Might not know about the files, I guess, though. Reminds me of the old Windows logo. It does, yeah. The 4 corners there does look a bit like the Windows logo, doesn't it? I don't know how long you have been tuned in, Quinman, but I will be wrapping it up here in just a few minutes as well. Getting towards the end of the stream here. I'll be back tomorrow morning at 10 a.m. Central Time if you're interested in similar CircuitPython development related content. Go. Perfect. So then the difference this time is that we don't have SPI. But I'm pretty sure that that means that we could not use the SPI bus, because if we tried to initialize it, I don't have the old code though. I think this remembers, it doesn't. try to do something like this. Was it GP 10 and 11? Doesn't actually have the right stuff in it. It's weird. I don't know where the I don't know why it's not. It doesn't have the rest of that stuff. Well, anyway, pretty sure it was GP 10 and 11. Whoops. Just a quick question, why do you have a tab with a cam showing the device instead of looking directly at it? So that I can show it on the stream, mostly. Yeah, I mean, for myself, I can just look down right at it, and that's totally fine, but if I want to be able to show whatever's on this display to you and everybody watching the stream, then I need to try to get it onto my screen somehow. Well, that's the easiest way. I could probably feed the camera into OBS and do it that way, but I kind of like it this way, where it's just a browser tab essentially, and I can just go back to it, and I already have my screen share and all that stuff set up inside OBS anyway. So when I pull it up here, then you guys are able to see it as well. I think we just default that to none on the last one there. So I'm pretty sure this should fail. Yeah. So that would be probably the next thing to test on this is if we put SPI back like this, then are we from user code able to look up the board.spy and use it to connect other things? I don't really know what else I would connect. We'd have to have a sensor or something that would connect over SPI. Honestly, the majority of the things that I use are displays. I guess there's the SD card. That's probably the easiest way, actually. That's probably the way to test this, is the SD card reader, which I forgot about. So yeah, maybe I'll try that out tomorrow. But like I said before, I'm not 100% sure what I'll be working on tomorrow just yet, but that could be something to try out. Anyway, I think I'm going to call it there. So thank you for watching, everybody. Thank you for sticking around through the struggles. I apologize if I was a bit grouchy there for a little bit in the middle. It's a bit frustrating having some things go wrong one after another, but we did make it through. I'm feeling pretty good about this. I definitely learned a lot, so I'm happy that I powered through and got it solved. Thank you again. Huge thanks to NearDoc. I probably would not have figured out the fetch submodules thing without NearDoc's help, which I am very grateful for. Thank you to everybody for watching. I hope everyone has a good night and a good weekend and all of that stuff. And I will see you around tomorrow if you want to catch the stream. Otherwise, I'll be back probably for a bit on Monday. And certainly back around next Friday for Deep Dive next week. So until then, see you later, everybody. Thanks for watching.